Hi guys, welcome to Introduction to Multiple Regression. So in this lecture I'm going to go through a bunch of slides and we're going to split it up into a few parts, and then finally after these slides are complete and we have a decent grasp on the fundamental concepts here, I'm going to show you how to perform the calculations with software. Okay, so let's get to it. So introduction to multiple regression. So luckily at this point most of you have, definitely in my course, have taken or seen the topic of simple linear regression. So many of the concepts and terminology transfer over directly into multiple regression, so we don't have to start from zero here. So let's get into it. So multiple regression basics. So in simple linear regression, if you recall, we had one numerical independent variable. We also call that variable sometimes a predictor or an explanatory variable. Okay, so I'm giving you a few synonyms here. And those variables, or that variable, was given the distinction of being called x. Okay, we have a very special purpose for the variable x in regression. Okay, and we also then had a dependent variable, which also went by a couple other names, the response outcome, and that was the variable y. We called that, whatever it was, y. That was what we wanted to predict or estimate. So that pretty much transfers over directly, except in multiple regression now, and the word multiple, you'll see why this comes up, is we'll have multiple independent variables now. So we're not only going to have just one x like we used to have in simple linear regression, but we're going to have multiple x's. Okay, that could be 2, 3, 4, or k. Okay, as long as it's more than one, it is multiple regression. But we still want to predict a single dependent variable y, and that has to be a numerical variable, if you remember, and so that doesn't change. So the only real change here is we have multiple x variables, multiple variables that we're going to use in order to predict the one variable that we want to predict, which is the y, the dependent rather. Okay, so the y variable is once again reserved for a variable we want to predict, which must be numerical in multiple regression, as it had to be in simple linear regression. It goes by several names, as I've already mentioned: dependent response outcome, y. Now we have multiple x's, so I'm over here, and hence multiple regression is what we're going to use. So remember, the x variables are the ones we want to use to predict the y variable, and that's the same concept as we had in simple linear regression. The x's go by these names as well. Okay, so I'm going to use these different terms throughout our lecture, so just be comfortable with them interchanged. Okay, so here's the multiple regression model. The basic idea is that we want to examine the linear relationship between one numerical dependent variable, the y, and two or more independent variables, so x1, x2, x3, so on and so forth. So this right here we're looking at is the multiple regression model with k. So k is obviously just an integer, a positive integer, of 2 or more. Okay, if k was equal to 1, that would mean we only have one x variable, and so all this would be crossed out, and all we would have is this here, and of course the error term, but only one x, so only one beta. Okay, so that becomes a simple linear regression. But since we have multiple, we have k of them, then this is multiple regression. So let's take a look at the model. So everything here is labeled and it has a subscript, so let me go through everything in this model here. So y is, notice it does not have a hat. This is very important, as it was in simple linear regression. yi is the ith observation of y, meaning whatever variable you're trying to predict, the ith row or ith record, okay, that's what this is. All right. Beta 0 is the intercept. That was the same intercept in simple linear regression. And now instead of just having one slope, beta 1, we have a separate slope for each of the x variables. So one for x1, one for x2, one for x3, one for x4, one for xk, however many you have. So these are called oftentimes partial slopes. Okay? And finally, of course, we have this error term. And the error term arises from the fact that this, in order to know exactly what y is, you can find the linear combination of the x's, that's up to here, but then that's not going to tell you exactly what y is. There's always going to be an error above or below this equation. Okay, if you remember in simple linear regression, we could actually visualize this quite clearly, and in a second we'll also be able to see an example. Okay, so the moment I remove the error term, this is no longer y, but y hat. It's estimated or predicted y. Okay, and that's important. Error term comes back, the hat is removed. And then pay attention to one other thing before we go on to the next slide. Here, these are the Greek letters, right? And we oftentimes in statistics reserve the Greek symbols for the population coefficients or parameters that we're estimating. So if you recall from very basic stats, mu was the true mean or the mean of the population, and we had x bar, which was the sample mean. Okay, and we used the sample mean to estimate the population. Well, we're continuing the same logic as we go into more and more complicated topics like multiple regression. We're never gonna really get to know these guys, although we would love to, because we don't ever really have the population data. So let's go to the next slide where I discuss this. So in simple linear regression, the regression coefficients. So the regression coefficients were all those betas that we were just looking at, right? Collectively, they're called the regression coefficients of the multiple regression model, but obtaining their values requires us to have complete population data. And since one of the central challenges in statistics is that we don't have population data oftentimes, we need to collect sample data, and then from the sample data, estimate what we're interested in, okay, learning about. So since we're interested in getting these guys, getting actual values for these guys, the regression coefficients, we're going to collect sample data and estimate these guys with these guys. So at least symbolically, I want you to be aware of the distinction and connection between this group of regression coefficients and this one. The one up here is for population data, which we rarely, if ever, have. And the ones down here are estimates of these guys, estimated from sample data. Okay? So when we're actually getting numbers later on in this topic, they're going to be these guys. Okay? So, and I explain this down here. B0 then becomes our point estimate of beta 0, B1 becomes our point estimate of beta 1, B2 becomes our estimate of beta 2, all the way on up, etc., up to BK becomes the estimate of beta K. All right? These guys we can actually get numbers for and values for. These guys serve as kind of what we wish we could know, or rather the targets of what we wish we could know. Okay? Okay, so we get to the multiple regression equation, and you notice what's different between this guy and the equation that we saw earlier is we have the b's here first off instead of the betas, and the y has a hat on it, and notice the error term is gone. Okay, so notice these things. The coefficients of the multiple regression model are estimated using sample data once again and result in the equation below. Note how the error term disappeared and a hat appeared on the y, indicating that this is predicted and not actual or observed y. And so that's very important. I state that over and over again. Okay, so this is the multiple regression equation with k variables, independent variables. So here's the y variable that we want to predict, and here are all the x variables we're using in order to predict it. Now, the rest of this stuff, you could see this is the intercept as you expected, and these are the partial slopes. Okay, to actually get these values now, we're kind of getting closer to that. To get the B0, B1, B2, etc. up to BK, we're going to use software. So choices of software: Google Sheets, Microsoft Excel, or if you're more sophisticated, we can use R, SAS, SPSS, whatever it is. We're going to use computers to get these numbers, okay, to get the regression coefficients specifically. Okay, so a little bit more on some theory before we jump into a little bit of an example. All right, so the multiple regression equation, here's a little bit more specific. So now imagine we have two independent variables, so that means we have two x's. So this is just a little bit more complicated than simple linear regression where we only had one x. Okay, remember, we're still only trying to predict one y variable. Okay, so if we had two independent variables, we could still visualize the relationship between them and y. So hence 3 variables in total, because the 2 independent and the 1 y variable, right? And how do we visualize this? Well, we're still in a dimension where we can understand. We're in 3D. So instead of getting those 2D scatter plots that we used to get, remember these, where we looked at something like this and we said, oh, x and y have some kind of positive relationship. Let's get the equation for that. Well, now we don't have just one x, but we have two x's. So we can still kind of see this because it's now 3D, but it's hard because it's like flat. We're trying to do something 3D flat on a page. So you can imagine as soon as we have 3 independent variables instead of 2, so together we would have 4 variables with y. All of a sudden you can't see a picture anymore. You can't really visualize a 4D plot. It becomes very difficult. You have to slice things up, and so that quickly becomes a kind of impediment we have to deal with. Okay, but in this case, in this simple case, it's not simple, it's still multiple, but it's only relatively simple, I mean. Okay, we can make a 3D scatter plot. So first off, let's look at the scatter plot. Okay, so here's y, right? So that's the variable we want to predict. Here's x1, here's x2. So you could think of these as the two predictors. Soon enough we'll have some context here. Maybe we're trying to predict sales of something using how much we spend on advertisement and radio advertisement and maybe online advertisement. These could be our data. But just think of them abstractly. X1, X2 are obviously the independent, and y is the dependent. So these points here, the red points, forget about the lines from the points, are the actual observations. So this guy right here, if we grab him, this guy has an x of some, x1 I should say, of somewhere over here, and an x2 of somewhere over here. Let's say it's very hard to see. So if we went x1 this far and x2 this far, we would go up straight, hopefully, and we would get the y, the observed y, for this particular observation. So each of these points represents one row, if you will, on a multivariate data set where you have three columns. You have y, x1, x2, and then you have some data here, right? And so each row here is associated with one of these dots. So each row is an observation. Each dot represents these observations. So if we have a sample size of n, we're going to have n dots here. You can actually count these red dots and you'll know how big our sample size was. So that's exactly how we learned to kind of look at the scatter plots in simple linear regression, except here it's just the 3D makes it quite difficult to kind of do too much with this, all right? And then you see that on top of these dots, or in between these dots, I don't have a line, but I have what's called a plane. So here you see this word plane. A plane is like a sheet of paper with the one rule that it has to be flat. Okay, it can't be curved. Okay, so that's something else. So as you can see, this thing's kind of curved, and you kind of can see that it's slicing through the points. So that is our equation here. So that would be the multiple regression equation in this with this example. Okay, it's trying to best fit those points. In other words, it's trying to get as close as possible to all these points, just like we tried to get the line as close as possible to all the points when we were doing simple linear regression, except now it's not a line anymore, it's a plane. Okay, so what I'm saying here is visualizing the scatter plot becomes nearly impossible once we have more than two independent variables. So multivariate plots become of minimal use in multiple regression. We can, however, make use of multiple 2D plots, scatter plots, to examine what's called marginal relationships between variables we're considering. And if you get all the possible scatter plots of all the different marginal relationships, you can put something together called a scatter plot matrix. All that is you would take, if let's say we have these three variables here, two independent, one dependent, you would take each pair and make a scatter plot. So you do a scatter plot of y and x1, you do a scatter plot of y and x2, and the last pair would be x1 and x2. So those are all the pairs possible if I had three. So I would look at three scatter plots and I would put them together in like one view, and I would call that a scatter plot matrix. That's all that is. And so since I'm looking at them a pair at a time, that's called a marginal relationship. Okay, so that's what this is here, marginal relationship. So here I would have three marginal relationships. I could look at the scatter plot matrix that would show those three, and I could see how the pairs are related to each other, even though I can't see how all three are interrelated to each other. Okay? All right. So these visuals become much less kind of useful in multiple regression compared to in simple regression. Okay, so let's go on. All right, so finally now let's get into an example. So I have an example here with two independent variables, this time actually with context. So we're a distributor of frozen dessert pies, and we want to evaluate factors thought to influence our demand. So our dependent variable is how many pies we sell in a week, and our independent variables, the ones we're going to use to try to predict how many pies we're going to sell in a week, are how much we charge for the pies, so the price in dollars, and how much we spend on advertisement in that week. And advertisement, as you can see, is going to be in hundreds of dollars. So we collected data on 50 randomly selected weeks, so they weren't necessarily chronological. Okay, we wouldn't want to do that because that would give us a lot of problems, namely with something called autocorrelation. But anyway, these are 15 randomly selected weeks. So let's take a look at the data. So here's the pie sales. So in this week, so each one of these is a week, and if you count these, we have 15 weeks here. So n is 15. So you don't have to think of this data as 15 consecutive weeks, just 15 randomly selected weeks. It's much better to think of it like that. Each row represents information or data on 1 week. So this for the first week here in the data set, not that that's the first week in order, we sold 350 pies. We charged $5.50 for the pies that week, and we spent $330 in advertisement. 3.3 because it's in hundreds, $330. Okay, you would figure if we spent more on advertisement, pie sales would go up. You would figure also that if we charged less, the price was lower, pie sales would go up. So these are all kind of ideas we have going into this, so we can kind of see if the numbers that we get for the coefficients kind of agree with what we kind of expect. Okay, so by the way, this is called multivariate data because we have more than 2 variables measured on each observation. In this case, we have 3 variables, right? This is going to be our y because that's what we want to predict. This is going to be one of our x's, and this is going to be another of our x's. Okay, and furthermore, we're going to use both of these guys in our model. So here's kind of this template for this model. We want to predict sales, so that's this guy, using the price, so that's our x1, and the advertisement, x2. And here are our regression coefficients, so we have to estimate these guys. Okay, so we're going to put this into either some kind of computer software, and I'll do a separate video on how to do that. And we're going to get this output. So estimating multiple regression equation, we're going to use Google Sheets, Excel, some kind of computer software to calculate the coefficients and other things, some things called measures of goodness of fit for the multiple regression. So Google Sheets, Excel, so here's just a little tiny bit of a preview of how I'm doing this. I'm using the add-ons called Excel Miner in Google Sheets, and I'm choosing linear regression. You could also do this in a very similar way with the data analysis tool back in Excel rather. Okay, so separate video on that. Here is part of the output. Actually, this is the whole output, just a little formatted. There's a number of things we want to talk about here. Let me actually pause this section and start a part 2 of this video where I'm going to start talking about this output in much more detail. Okay, so keep watching this, the introduction to multiple regression, part 2.